Hi, I'm Nicole Tetreault, and I am thrilled to be speaking with you today. I'm a neuroscientist who has studied developmental, neurodevelopmental and neurodegenerative disorders for many years. And most recently, I've really focused my efforts on studying giftedness and twice exceptionality. And more importantly, I have a book that is going to be released March 2nd, 2021, called Insight into a Bright Mind, which has all of this information and so much more about what it is to be an unconventional thinker in this day and age, and kind of really reshaping and rethinking what we think intelligence is. And so I'm delighted to be here with you today and share in this moment. And so let's get started. I'm going to talk to you about the brain, and I think we're going to have a lot of fun. So why study giftedness? You know, for me, when I really came into this, I came into this not knowing I was going to study giftedness. My son was in third grade and he was identified reading at college level. And everybody says, oh, that's so awesome. The kid's just ready for college. He's going to be fine. And there was sort of another story that was going on. And being his mom and being a neuroscientist, we sat in the parent-teacher conference. And what I learned was my son was spending most of his recess and lunches in the library. And me and my brain thought, oh my gosh, I'm so worried. He's not going to have social connections. And I was really stressed out because I thought, you know, his childhood should model mine. For me, I went out and played on the playground, and I was the psycho on the playground saying, come get me with the dodgeball. And he was having none of that. He really did not want to talk to kids during that time. And more importantly, he wanted to really go to the library and have quiet time. And during the parent-teacher conference, he said to us, you know, Mom, I really need time to decompress and take moments away from these other students. And it's a way that I kind of recharge. And it really reshaped, and I started to think about it, and his teacher said, see, there isn't anything to fix. He's already self-regulating and he's already doing exactly what he needs to do. And as a mother, what I've learned time and time again is how much that I need to listen to what his experience is and figure out ways to support him in conjunction with the importance of talking to the teacher and listening to the teacher, and also communicating to the teacher back and forth about what his experiences are. And so that's how I really came into studying giftedness, because there was also another thing too, is that on the playground, he didn't really love being touched by other kids. And he didn't, you know, he wasn't the kid who wanted that physical contact. And, you know, it really woke me up to how people navigate differently in the world. And you know, a lot of these times we're kind of fed to fit in this box, fit in these constructs, and be a certain way. And if you sit still, are quiet, and, you know, do your work, you know, you kind of fly under the radar. But at the same time, a lot of gifted kids sitting still is challenging. And they really kind of feel that they don't fit into normal, and they kind of think, am I normal? And this study came out that would just kind of rocked my world. It came out 4 years ago. And what they did is they looked in the brain and they found that basically there were 97. So in graduate school, I had 86 brain regions I had memorized, and you kind of know what they do. And it's sort of this area of the brain, you know, is responsible for example, frontal cortex. It's responsible for executive functioning and processing. And so we were taught these very specific brain regions. And this study really had the software where they were able to parcelate the brain regions even deeper to where we had 97 new cortical brain regions. It was twice the number that we had previously known. And so then there were now 180 distinct brain areas in the human cortex. And it kind of really blew me away because the software also really allowed for individual brain anatomy, where you could have something almost like a brain print or a brain, have a fingerprint as simple as your fingerprint as being a brain print. So each of us really has our very own individualized, unique brain. And that is pretty incredible when you think about it. And I really love to tell this saying from Maya Angelou. She lived, and she's kind of one of these really remarkable people where she lived in a time where she suffered great traumatic experience, and she didn't speak for 5 years. She was a selective mute, and she became a poet laureate. But if you think about it, there were many years that she wasn't sharing who she was with people because she didn't verbalize due to the traumatic experience. And, I love her phrasing, if you're always trying to be normal, you'll never know how amazing you can be. And a lot of these kids don't fit into what we call the so-called normal. And more importantly, as parents discover their kids are gifted, that the parents like, oh, I didn't know I was this quirky either. So it's sort of this this awakening that it's okay to not fit into these constructs. And so I really want to talk to you today about the brain, which is one of my favorite things in the world to talk about. And it's, and I'd like to tell you that, a lot of this research was done where I looked in over like 1,000, studies. My book has over 400 references in it, to where I really wanted to tell a unique perspective where I interviewed people and talked about the brain. And so what I'm going to tell you about the brain is that we have it parcellated into very specific brain regions. We have the frontal lobe, which is here, which is essential for reward, attention, planning, short-term memory tasks, and motivation. We have the parietal lobe that really integrates sensory information, including spatial navigation, touch, mechanoception, major sensory inputs from the skin, and temperature and pain receptors. And then we also have the temporal lobe, which is really essential for visual memories, language, and emotional connection. And then the occipital lobe is really giant in the back of our head, which is important for visual processing in the way we take in our visual senses and motion. And so I'm going to tell you just briefly in the brain, when I talk about gray matter, what it really is the neurons in the glia. So that kind of is the bones almost of the brain, where you have all the processing happening, where information is kind of parcellated through. And we know that we have these cortical regions that allow for information processing. And then we have our white matter, which is basically, I like to kind of think about it as the freeway systems. It's the way that information travels from one brain area to another. So say, for example, if you're looking at something in your visual cortex and you need to make a motion using your motor cortex, and then on top of it, you need to make the decision to move, that's going to go all the way to your frontal cortex to make that. And so you think about it, these freeways are the way that information travels from one brain area to another. And so the thing that I really want to talk to you about that I found was such a foundational study by Shaw and colleagues done at UCLA in 2006 was they took over 300 children and they brain scanned, you know, they did maps of their brains in the scanner over a 12-year period. And what they found when they looked at the brain scans in these children, they also had them all take a IQ test. And what they found is that they had the children go into 3 different groups where you have blue here, which is in superior, high intelligence, which is in green, and average intelligence, which is in red. And what they found was that the blue, which is superior intelligence, had a rapid brain growth beginning at age 9, and then it kind of tailed off at around age 14. But what they showed in particularly is that the brain doesn't grow all uniformly, that you have this real asynchronous brain development. And in particular, you have the area of the brain called the frontal cortex right here, which is kind of the holy grail for your emotional processing, your executive functioning, the way that you kind of have valence and make decisions, and the way that you have learning and memory happen. And so what they found is that this brain area really expanded in the higher IQ individuals starting at age 9 during puberty. And they found that also the somatosensory cortex and part of the parietal cortex grew as well. And what's really important to think about here is that this frontal cortex really does not develop until all the way in our mid-30s. So it's still expanding and it's still growing. And another thing that I really like to point out here is that when we have this asynchronous brain development, we also have asynchronous behaviors that correspond to it. You know, so I like to always give the example that imagine you have a child who has really great ability in processing sounds, so they can hear things at a very elevated level, and they have high receptivity to it. Now imagine that same child, 3 years old, doesn't have that frontal cortex totally fully developed. And so what happens is that they're kind of on the brink, maybe certain sounds to them can cause pain. And that in particular, if they're experiencing pain, what happens is that child can have a moment where they have a tantrum because that frontal cortex isn't totally developed. And so basically they kind of get tagged with this bad behavior, but it really has to do with the fact that they're not fully developed in their brain to be able to communicate and say, the sound is causing me pain. It's causing me difficulty to concentrate. And so I really always like to point that out because it's really important. So often than not, we get these kids where they're told stories that, oh, if you're gifted, you should be able to be doing everything at a very high level. Where in fact, I think being gifted educators and parents, you know, you really see that there are these asynchronies. And what I like to point out is that people have these extraordinary abilities, but they also can have, you know, challenges that they're dealing with. And in particular, you know, I like to point out, say for example, and this was kind of my son, you know, you have a kid who's reading, you know, 5 grades, 10 grades ahead, and then when they get to the test, you know, they have dysgraphia and they can't really be able to write out, you know, their answers. And I'll give you an example. My son, you know, would read a book rapidly, and he would talk about it for 45 minutes on stop. And then when it came to the test, he would just say the book was good. And there was kind of, there was a disconnect in the ability of what he can actually say and do. And then once we got him directly on typing, he was able to really, you know, type up paragraphs about what he read. And so the point that I'm making is that giving the proper supports really makes a difference. You may also have a child who is profoundly gifted in art, but they could be a child who gets really lost in a project. And they can actually even lose that important project where, they forget to turn it in on the day because there was so much work put into it that their brain, they're not paying attention to timelines. And then you also can have a child, for example, where they're, mathematically gifted and visual spatial, and then at the same time, it could take them a really long time to learn how to tie their shoes. And you know what? I had difficulty tying my shoes, and it turned out, I think, okay. So, there's these developmental milestones or expectations, and I kind of put expected because as we know more and more with asynchrony in brain development, we know that that's going to correspond to differences in behaviors and reactions. And so more importantly, we need to really nurture the child where they're at, not where we expect them to be. And so what do I think's happening in the gifted brain or in a twice exceptional brain? Is that basically what happens is this frontal cortex area right here, I think really because it develops all the way into our mid-30s, that making executive functioning and decision-making takes a little bit longer to develop these behaviors. And in particular, you can have a child where you can have their processing speed can either be too fast, where they come off kind of very excitable and hyperactive, or very slow and they kind of seem like a drifter or kind of out there, having to specifically do with the way that their brain processes information. And I'm going to get into a little bit more about that when I talk about the white matter in the brain. But in particular, when you think about it, it could happen in two different ways, where you can have a child who can, I always like to use the example of a banana. You can have a child who, you ask them a question, what color is a banana? And you have a child who says yellow right away. And then you have maybe another child who's going to say yellow, green, blue, brown, white, because actual banana is a little more cream. And they may take longer because they're kind of going through all these different ideas in their mind. And then you can also have it where it just takes longer to process all that information. And on the other side, you can have a child who basically, takes longer to process because they're thinking about all the possibilities, or they're, in addition, they can have a child where, they think so rapidly that they are so overexcitable that it becomes, a little bit where they're speaking out of turn and not waiting their turn. And so one thing I came across this year that I thought was pretty incredible was they looked at children in a scanner and they measured how individuals learn information. And what they found is that each individual has unique brain network activation in response to learning and thinking. And more importantly, that executive functioning predicted how well the brain worked together in the pathways. So if you had really good executive functioning, then the brain network pathways were laid out very clearly. If there was problems in executive functioning, then the connectivity across the brain and these networks wasn't as well defined. And what they found is that really in adolescence, as I showed you in that earlier study, that brain networks really reorganize and develop in adolescence. And that these brain activation patterns really were predictive for maturation of an individual's brain. And the important thing is that there's a real vast plasticity and diversity in brain anatomy during development. So, not only is each individual brain developing asynchronously, but individuals' brains don't even look the same. And so I think that's a really important thing. In that really what they found is that when you can personalize individual therapy for that particular individual, it made a difference in how their brain actually developed. And so, you know, I really always like to talk about how we know in science that gifted individuals do have expanded brain regions. This study was done in 2008 with Choi and colleagues, and what they found looking at brain maps and imaging, that basically higher IQ individuals had greater volume, brain volume. And we know this to be true across species. You know, the larger brain, evolutionarily mammals who have larger brain regions, especially the frontal cortex, tend to have greater intelligence. But more importantly, you know, I point to this in my book where I talk about, you know, it's not just having larger brain volume, it's really how the entire brain works together. In that, you know, we need to really kind of get out of like, oh, it's a bigger brain thing. In that it has to do with, it's really a neuro-individual brain that's developing that may have areas that are large. What they've also shown is that in multiple studies that the white matter that I was talking to you about, where brain areas communicate to each other, they found that there's greater connectivity and congruency in white matter in these freeway systems in the brain of higher IQ individuals. And so having, you know, greater brain volume for white matter is going to allow greater processing speed. But what I like to get into is this idea of the white matter paradox, where we know that, pardon my slides, we know that basically when you have white matter, that it's really dependent on how well the networks work across the brain. So for example, when the connections are so fluid within a network where they're all lining up and they're kind of going in the same pathway, like so, then you're going to have greater brain processing and ability. But we know that in the developing brain that the pathways kind of look a little bit more like this, and they take longer to detangle. And so that could be one reason why brain processing is a little bit slower, is that the development of more congruent pathways aren't developed just yet. But we do know that when you have the pathways that are going in the same direction and it's more uniform, then you have that greater ability to have information processed more rapidly between brain regions. And we know that in particular that when the fibers flow really well together, that you get a better efficiency and better brain processing. And so that's kind of what I wanted to point out about the white matter, is that you can have more, but it really matters how the networks are aligning and if they're aligning in the proper way. Another really interesting study that kind of flips all of this on its side is how gifted brains really, or higher IQ individuals, have fewer connections at the microstructure. And so we know at the base of neurons, we have these ways that neurons communicate to one another using dendrites. And what we find is that there are fewer dendritic arborizations. They're like trees where they kind of feel each other out and talk to each other. And there's fewer of those in the brains of higher IQ individuals. And it's sort of paradoxical, but what we do know in development is that that a pruning happens in the brain for neuroplasticity, and that basically you have these kind of clearing of the branches so you can have information processed more fluidly and more efficiently. And so I just kind of wanted to throw something out there that is counter to everything I've been telling you, because I think it's really important that we don't get so oversold on what it is to be a gifted brain versus a twice exceptional brain versus a, you know, a normal brain, because the biggest thing that I want everyone to kind of come away with is that we're neuro-individuals and we each have our own individual brain and development. And that over time, we have, these processes that, can develop and be nurtured through training. But more importantly, one study showed too that when young boys they're gifted boys and they're in the MRI scanner, and this is called functional magnetic resonance imaging, fMRI, where they give you basically a cognitive task to do. And in this case, it was gifted boys where they were teaching them, having them do math problems. And what they found was when they gave them math problems with greater difficulty, that their brains were more activated bilaterally in the frontal cortex, but more importantly, that as the problems increased in difficulty, they were using more activation, meaning more brain energy, more glucose. And I mean, what they measure is the blood oxygen level, which is basically energy. And so, this increased activation is really related to intellectual engagement, where they're working at their level. And it's important to know that when a brain is engaged, it's a happy brain, and it's really engaged with meaningful material. And what I like to point is that, sometimes you may have a child in your class where they kind of get through all the exercises really quickly because it's easy for them. And perhaps they need more challenging work to kind of allow all cylinders to be firing. And in particular, sometimes you might have a child who kind of really fades out in class because, they're not engaged with the material, and they can kind of seem problematic. And more often than not, when the child is given kind of the proper intellectual stimulation, that child is able to really engage with the material, and the behavioral challenges really kind of fall away. And this is a really important thing to think about in your classroom, as I was saying, how more often than not, when it comes with learning certain materials, that gifted individuals need fewer repetition when learning new concepts. Sometimes some of these kids know something right off the bat and they don't need that repetition. And more importantly, what we know is that when people are doing a repeated action of something that they already know how to do, brain activity goes down. So basically their brain isn't engaged. They're not fully activated. And so that being said, it's really important to pay attention that a child is getting the proper level of information and engagement for their particular type of brain. And that really means that, sometimes you may need to, skip, 2 or 3 sections or maybe even a year to get them, really activated and working at their level and at their potential. And, I like to ask, but I can't really see how many are going to respond, but how many of you have children in your classroom or adults who are emotionally intense? And there's actually a signature in the brain for it. Scientists found it by happen chance. What they did was they were looking at white matter connectivity in the brains of individuals. And what they found was this area called the uncinate fasciculus, which happened to be larger in higher IQ individuals. And at the time they were saying, what does this area do? And they knew that it connected the emotional area of the brain, the limbic brain, the limbic region, to the frontal cortex. And what they found was it was larger. But at the time, scientists didn't totally know the purpose of it. A study came out in 2015 where they found that individuals who had lesions to the area, whether it was due to a stroke or individuals who came back from, who were vets who had traumatic brain injury and had a lesion in this area, they found that there was a decrease in the ability for empathy and, having that emotional intelligence. And so what I want to point out is the area that I'm telling you is expanded in higher IQ individuals is really essential for empathy. And so when you think about that, you may have a child yourself or a child in the classroom, somebody who, kind of holds on to the idea when somebody cheated in class and they, want that moral justice. They want that they have that deep empathy for seeing somebody who's homeless on the street and wanting to make change, that it's really related to their brain being developed and that it's hardwired that way. And so it's really important to know that, high emotional intensity and empathy, is related to having a brain that is developed that way. And so, that emotional processing could come out in a number of different ways. And in particular, we know that, these kids can have, an increase in emotional intensities where they can have higher rates of tantrums. They can have higher, inabilities to kind of get out of a rumination pattern or have more challenge kind of settling back into their nervous system. And I'd like to point out too, some of these kids can even have an emotional drive for intellectual curiosity, and that those two areas could kind of be woven. And so it's really important to kind of pay attention to that. And it's not that this is something that's just random. Ruth Karpinski, who is gifted herself and is a gifted adult, she went back to college. And she decided for her thesis that she really wanted to underpin and understand how and why she had two sons, one who was gifted, both are gifted, and one who really struggled with anxiety and ADHD. And she really wanted to understand if there was an increased incidence in depression and anxiety in higher IQ individuals. And what she did is she did a questionnaire where she looked and had people who were Mensons report in this questionnaire their rate of diagnoses. So diagnoses you could see here is in orange, and that's a Menson population. And then the high intelligence combined is basically was diagnosed by a doctor or self-diagnosed. And the reason she added in the self-diagnosed is more often than not, people don't go to the doctor for mental health challenges that include anxiety and depression. They kind of feel like it's something they have to live with. And so she was very curious about that as well. And so what she found is that higher IQ individuals had a greater instance of depression and anxiety, but in particular, she was looking at this, and there's about a 25% increase in higher IQ individuals to have anxiety compared to the national average. And that's across all anxiety disorders, which is general anxiety, social anxiety, and having, OCD. And so it's a really important thing to think about individuals that are suffering of anxiety. And what I like to point out is that in this, we know that there's kind of these waves of emotions that people experience. And in particular, of these emotions, we know this study was done where they looked at college students and they had them measure their emotions from the initial onset that they experience the emotion to the duration that it lasted. And then they also wrote ways in which they dealt with managing that emotion. And what the scientists found was that basically, for example, sadness lasted 120 hours, whereas joy lasts 35, anxiety lasts 24, gratitude lasts 5, fear lasts 45 minutes, and disgust lasted, a half an hour. And so it's really important to think that, I'm telling you that high IQ individuals are kind of predisposed to having greater anxiety and depression. And in particular, we know now from the study that anxiety lasts, on average, 24 hours. But more importantly, that, for a person who's profoundly gifted, that anxiety could be prolonged and it could really turn into an anxiety disorder. And so it's kind of something to keep in mind. And, at the same time, it's really important to notice that we can help a child who's struggling with these kind of complex emotions and patterns, where we can induce, kind of trying to bring in joy into their life, bring in hope, where those kind of emotions last 24 hours and 34 hours, 35 hours for joy. And so ways that we could kind of shift our narratives and shift our stories and kind of bring in more positive emotions. I have a whole other talk on that, but and about anxiety. But in this point that I'm really trying to make is that, this is kind of a baseline of what we see. And, for me, I kind of always like to tell a story. I was dealing with kind of a really sad scenario. And the moment that I recognized, and I had read this study, I said, okay, sadness is going to last me 120 hours. And it was almost like I gave myself that 120 hours. And then when I told myself that story, it actually dissipated in 48 hours because I knew that there was an impermanence to it. I knew it wasn't going to last forever. And I think the way that if we can help children kind of label and note their experiences rather than I am feeling sad, but have them say I'm experiencing sadness, but having them and teaching them to be able to verbalize their emotions really helps with processing and paying attention to the impermanence. That, for example, I always like to say, imagine you're going into a surprise birthday party and it's for you, and you show up, at the same time you walk into the room, you could experience joy to see everybody. You could be embarrassed. You could be frustrated because you're like, I didn't know, I would have worn something different, whatever it may be. And so I think that, you can have multiple emotions at once, and you could really decide what emotion you decide to run your moment. And in that, when you're in the presence, you can really cultivate an awareness of your emotion and even shift your awareness to a more positive state and emotion that you want to experience. And coming back to emotions and education, this study was done by Cantor in 2018, where they found hands down that emotional connection is the primary way that children learn. That the emotional connection needs to be really founded in 3 forms. 1, in the home of the child, where they need to feel that emotional connection and safety and security. 2, with the teacher and with their school, and 3, within their community. And when you have those 3 pillars, the child can thrive. But most importantly, we know that, when a child feels cared for and they feel that excitement about information, that they're going to be naturally drawn to that experience and be drawn to the presence of that. And so what I want to point to you is that what you do on a daily basis your presence of being there for children and having that emotional connection makes all the difference in their ability to thrive. And, you know, to kind of leave you with learning and neuroplasticity, I really hope that you get from this talk that the brain is a dynamic organ that has the ability to develop. And we know the Hebbian notion, neurons that fire together, wire together. And so how we cull our brain activity, our behaviors, our reaction patterns are all related to how we develop. And that we do know that when we practice a good task, you know, there's this misconception that it takes 20 days to learn something new. It actually takes on average more like 66 days. And it's to be more encouraging to you and to your students that to kind of hang in there and really work on, you know, on new types of things to shape your brain and shape your body experiences. And we do know that we can cultivate positive neuroplasticity, you know, positive thought processes, positive ways that we interact with the world, and that, you know, we aren't these beings that are just set and that's it. That, you know, we're learning more and more that the way we nurture ourselves really shapes and defines our circuitry, defines the way we are. And in that we are these neuro individuals that have the ability to kind of shape into who we want to be. And then there are things that are, you know, innately within us, but that we have the ability to kind of build positive neuroplasticity. And, you know, the best way I really recommend to support a 2E learner and a gifted learner is create a safe environment where they can process their surroundings, speak and behave freely to be themselves. Identify the origin of their learning style, find out what they love and let them run with it. Engage with like minds through activities. You know, a lot of these kids feel isolated. And the minute you get them into an activity where they're doing something they love and they find somebody who does it too, there's that parallel play. Allow them to learn at their own pace, implement appropriate accommodations for them, and encourage divergent thinking. You know, when they say something that's out of the box, really encourage them and let them know how magical they are and the kind of being that they are. And, you know, the primary way, one of the key ways to really enhance our way of being is through social connection. Social connection is the primary way that it erases that social isolation. It erases, you know, these behaviors that, you know, can be harmful to us. And when you have these social connection, it's the number one way to increase meaning and purpose and really longevity in life. And, you know, that was the one thing that James T. Webb, you know, he was one of my mentors, always told me was sometimes for gifted kids, it's a lonely thing out there and people kind of march to their beat of their own drum. But what we know is that when you have 3 deep social connections, that basically it keeps you as a deep integrated person in being in society. And so if you could really teach these kids and help them find these meaningful connections, it makes such a difference in their life. And sometimes that connection, of course, is going to be with you as their teacher. You know, teachers are incredible at seeing their students and pointing out their uniqueness. And so, you know, I'd like to leave you with one of my heroes, Fred Roger, says, as human beings, our job in life is to help people realize how rare and valuable each one of us really is. That each of us has something no one else has or will ever have, something that is unique to all time. So just thank you for all of the work you do with these children, and being here today and sharing in this time with me. And it was an honor and pleasure to talk to you about the brain. If you have any questions, please don't hesitate to contact me. This is my email, my website, where you can read some articles about the things that I talked about. My book is going to be out this March, so if you want to get that, go ahead to Gifted Unlimited and pre-order. And may you stay safe, healthy, and may you be free. So have a wonderful rest of your conference. Thank you.